Hello everyone, my name is Chetan Agarwal. I am in BSMS Physics third year, and today we are discussing about our project stress analysis of handwritten answer scripts using the natural language processing or NLP. So I am working in a team with Abhijeet, Kumar, and Pronoy. So chapter first is a basics about what we are doing in this project and what are the basics software we are using in this. So first software is PDF to image. The PDF to image is a tool or software library you can say used to convert PDF pages into a image format like PNG or JPG. And in this project we are converting PDF to PNG format. Second is OCR. OCR is a technology that converts handwritten text from images to a editable and searchable digital format. So we can, the computer can't understand the images, so we convert images to digital format and then we can further use transformers into that. So the next is transformers. Transformer is a digital architecture designed to process sequential data. They use a mechanism called self-attention. So next is SciPy. SciPy is an open source Python library used for scientific and technical computing, and it is basically built on NumPy. The next is PyTorch. PyTorch or Torch, you can say, is an open source deep learning framework by Meta, which is used for GPU acceleration, which uses our device less power and we can do our work efficiently. The last is JSON. JSON is a lightweight text-based format used for storing and exchanging data.
So, hello everyone. My name is Pronoy, and I am also part of this team. And first of all, I will discuss that why we need to use handwriting as a metric to understand stress. So, let's imagine a situation of an exam hall where two people are writing their exam, and one of them is under stress while the other is not. So, the left one, yeah. So the left one shows the answer script of the less stressed person, and this can be evident from the fact that the words which he or she has written, has somewhat evenly spaced, or somewhat evenly spaced, and there is a consistency in the handwriting. So the person has a consistent stroke speed, pressure, and hasn't changed the amount of slantness in his handwriting. While on the other hand, the right side person has somewhat difference in the gaps between the two words, and the slantness of the letters are also different. Like you can easily observe that in the placement word, the P is much more slanted than the one in the word pulse. So this can easily show that the person on the right is most probably under a bit of stress. So the aim of a project is to use factors like stroke speed, pressures, slant inconsistency, and uneven spacing, and mathematically correlate them with their heightened stress. And using NLP models for the same is the key to this project.
Hey everyone, I am Abhijeet Kumar. I am also the part of this team. In this section, I will discuss about the analytical challenge of the stress analysis of the exam paper. So basically, what we are trying to do is that we wanted to quantify the stress of a student during the exam paper by judging the emotional tone, word choice during the exam, writing the exam paper, and handwriting simulation. So we will take the help of natural language processing for this. So the core problem is that we aim to quantify stress by analyzing subtle of some conscious features in their handwritten examination script. This deep dive moves beyond more skirts. And the second part is that handwriting and cognition. The act of handwriting under pressure can reveal cognitive load and emotional state. NLP offer a powerful lens to decode this complex relationship. For this, we have to do a forensic analysis of whatever we are getting the data. We have to analyze each and everything. This research fall under academic forensic, providing objective, data-driven insight into the student's examination experience, enhancing traditional evaluation method, etc. For the very beginning, for any project to start, we have to set up our environment in our personal computer. So in this project, we are doing the environment setup by downloading some packages, upgrading it, downgrading it. As we are using Python 3.11 for this project, so we have to upgrade some packages, or even we have to downgrade it. To enable seamless automated text extraction, environment is configured with optimized OCR, that is optical character recognition, and image preprocessing pipelines, ensuring accuracy and reproducibility across all data samples. Uh, for OCR model selection, we finalize to transfer based optical character recognition, that is from Hugging Face deployed. It is a free model that is available in the Hugging Face for handwritten text decoding. It uses a pre-trained vision encoder and text decoder for converting image pixels into textual tokens. For hardware acceleration, the system automatically detects the available hardware. If GPU is available, it will work with GPU plus CPU. And if only CPU is available, it will will be compatible with the CPU. And so our project will be compatible with only CPU as well. For processing pipeline, the pre-processed image tensor are pass through the transfer OCR processor and generator, followed by the token decoding. We are using the transformer model for token decoding. We are using auto token decoder model, so that we just have to switch the model name. We don't have to change our entire code for change. This pipeline maintain a consistent result through fixed parameters like beam, search width, maximum token length, etc.
So now we will discuss about the input data set and why it is important. Because for any NLP or any model or project, the data set is must. And data set, if the data set is great, then the model prediction and results will be great. If the data set is not great, or you can say the data set is absurd, then the output will be bad. So what are our input data set? We can see the overview. The data set used in this project consists of handwritten answer scripts collected from students during the exams time. So we have collected the answer script, we have scanned this answer script, and the answer scripts scanned are in the format of PDF. So each sample represents a bunch of scanned pages to handwritten text, and then we analyzed it. So we analyzed to study stress indicators present in handwriting patterns. What are the dataset description? It is handwritten, the type is handwritten scanned answer sheets. Sources that we have collected from the students itself. And it has very high resolution images, but in the PDF format. So we have to pre-process the images or pre-process the dataset before giving to the NLP or before doing the any after works. So first of all, we are conversion of from PDF to a high quality PNG format or JPG. In this, we are converting to PNG format. So we are converting PDF to PNG because PNG we can further analyze it. So after that, we converted this PNG format to grayscale, and then we have enhanced its contrast to ensure consistency and eliminate the noise before the OCR phase. So before the OCR phase, we have to pre-process the data well. We have converted JPG to PNG. Then the PNG, once the PNG images are enhanced the contrast, and we have grayscaled it, then we have binarized it to give to the OCR model. The next is data processing pipeline. So we have sort of created a data processing pipeline which we can automate, and we can only give the PDF, and further we directly get the binarized form. We afterwards see the results also. So we have created a successful analysis hinge on meticulous data collection and pre-processing. We have transferred the raw physical document into machine readable format. So scanning the raw script, formatting conversion PDF to PNG, then image pre-processing, which consists of contrast, binarization, and then we can give to OCR. So this is format conversion, PDF to PNG. The code is there. So firstly, we have imported the libraries. We have done the PDF to images library and pathlib library. So we have imported the particular libraries. Then we have defined a function PDF to images, which takes three variables: PDF path. R directory and DPI equal to 300. So what are their meanings? So PDF path refer to the path of the PDF file. We have created a PDF file. We will pass the path of the PDF, and then out directory is a folder where images will be saved. So we have given the path. There is a folder we have created where all the images will be saved. And for a resolution, we have fixed to 300 dpi. Then we can check if the PDF already exists or not. If the PDF already exists, it will take and go further. If PDF does not found, then it will give PDF does not found error. So if we do not this if we not do this step, it will directly do error. But in this, it will raise a file not found error, and we can know the PDF file is not there. Next, we have created a output directory. So by this, we can say out directory is path, and then out directory dot mkdir we have make the directory that create output folder if it does not exist. Then we are converting the PDF file and DPI setting. Then in this, convert PDF to images. Convert from path. So in this, what we are doing, we can say convert all PDF pages into images and stored in a list. So we are taking a PDF file. Then we are converting it to images. We have made the function earlier. And then we are storing all the images in a list. So why in a list? Because we can access freely afterward. So in the next step, we are accessing the images and storing by their converting them into PNG format, and then storing by the particular names. By that you can say we are what are the names of the file? The file names are file name underscore page underscore one. So by this, you can see there is a student name, then page, and then PNG format. So we can particularly hold the file names like this. This is the example. There is a PDF file earlier we have given to us, and this is the output of PNG file. There is a PNG file name which we have set, and we convert PDF to PNG. Next is image pre-processing, grayscaling and binarization. So first step is done. We have converted to PNG. The second step is grayscaling and binarization, which is more important. So what we have done in grayscaling, we have done grays. So we can say the images particularly. There is a PNG image file and this is binarized file. So grayscaling helps. This is blue ink and this is blank ink. So the OCR model will get confused by blue and black. It cannot recognize color. So we have changes to grayscale, only white and black, so it can particularly see the text only. And then minorize. What is binarization? We can see. So first of all, we are creating a rectangular kernel used for dilation. We are thickening the word strokes. So there is if this is single stroke, we are converting to 1.5. Then we are loading the images to grayscale, and if any image is not found, it will throw an error saying skip if the image failed to load. Then this is also thresholding. What is it? So it separates foreground ink from background by minimizing the intra-class variation. What is intra-class? Intra-class is between the foreground and the background. So there is a background page and we have written on that. So this is the ink foreground. So we are separating the background from the foreground and we are extracting the ink only. We are extracting the written part only by this. So, and there is, you can see there are two numbers, 0 and 255. So we are using an 8-bit grayscale images. So 0 refer to pure black and 1 refer to pure white. So 1 you can represent by 255 in grayscale or binary coding. Then we are converting images. So we have created the threshold and we are creating the grayscale images. Then we are inverting the color because it helps in processing. So we are inverting the color, we are thickening the ink, and then we re-invert the image and convert back to normal colors and save the final design image. So firstly, what we are in short we are doing, we in this, we are converting to PDF to PNG. Our PNG files are stored in a format we have seen. This is the PNG format. And then we are transferring the PNG format files to our kernel and it then grayscale it. We have seen the code. It grayscale it. It then use a also thresholding, which uses intra-class variation, and then it convert into grayscale. Grayscale images are then inverted color and then reinverted for this because this is a binarized code. There is a construct output file name. What is it? It is binarizing it, and by binarizing I mean this is 0 and 1. There is a 8-bit binarizer. So and we are saving the file name as file image, final image. You can see the output we have seen. There is a student6.png file, which is PNG file, and the final output is student6 page for binarized.png. So what you are saying, there is blue ink in PNG format, but in the binarized image format, there is only black ink. You can say black and white. So it converted to black binarized form. It converted to black image. Now we are very easy. It is very easy to extract the text from it. It do not convert that if there is a red part, so it do not convert that red is more powerful or blue is different from black, so it can only see this.
So now we are going to discuss the key part in our project, which upon which the working of our data set depends, which is the OCR or the optical character recognition technique. So what is OCR actually? So we got a data set in the form of PNG, and it has also been binarized as we saw in the previous part. Now what we need to do is detect those words, the letters which are written in that. And without that, there is no point of moving on. So OCR can be has two common structures which are available to us freely. First of all is the neural network based CNN based model, which uses the fact that we can use several perceptrons and arrange them in layers to detect our image, to understand and match the image with the standard images which it is already trained on, like, and it is connected like this, and with and the end one, the output node gives us the letter which it recognizes. However, this model is actually too simple for us and we can't use this. The model which we are using is a TROCR or transformer based OCR model. And the advantage in this is that it uses a transformer. So what is a transformer basically? So transformer has basically two components. The first one is the decoder and the second one is the encoder. So what we are doing is that the input images are given to the transformer from this end to the decoder. And what is happening is that it is already trained basically. So we are using a trained transformer. So it has the parameters already defined and all, right? So what it does is that it has several layers which upon which it works. So first of all, there's a decoder layer followed by the which it also follows a self-attention mechanism in which it uses a multi-layer perceptron to fine-tune the few of the parameters according to our need, and further it eventually matches the input letters to the ones which it has stored. So this actually works better because it has a much more complex structure, and it uses a tool called the cosine similarity, which in which what happens is that first of all, it vectorizes the input images into the letters in the input images, and it compares with the already existing letters which are stored in the encoder. And during that comparison, it kind of takes the dot product of these two vectors which it has formed. And the higher the dot product, the more it is close to that letter. And in this way, it is understanding which letter represents which image represents which letter, right? So this is the model which we are using. And yeah, we actually went and checked few models which we could use. So the OCR has two models, base and large. And we also checked out calamari, paddle OCR, and tesseract. But eventually we moved on with the TR OCR large model because it was working the best. And some of the models like the tesseract model required API integration. So in that we used the OCR APIs and we connected it to that and ran. Right. Now let's come to the code. So the code involves so this code is actually a bit pipeline based. So only thing which we need to change is the model name, and we can write any model which is present, and that would work on it, right? So here, as you can see, we have the Microsoft TROCR large handwritten model, right? So this TROCR model, it is also called a vision encoder decoder model, as I explained in the previous slide. So uh, it has a TROCR processor, and we got it from Hugging Face, and it is designed specifically for handwritten text recognition. So generally, it is not able to. It is specially designed to understand if handwritten word or letter is which letter, right? So the processor handles both image preprocessing and text decoding. So it has its own image preprocessor, and it is it decodes the text and eventually understands what it is written, right? So this encoder decoder architecture of TROCR has the two components. The vision transformer is the encoder, and the GPT-2 based model is the text decoder. Yeah. Now in the next snippet of code, here what we are doing is that we are giving the image path. Like here it is student 6 page 5.png, and what we are doing is that we have imported these images, and we have ran on it, and we are doing bash decoding. So it is running on the max length of whatever the max length is defined here, which is 512, and the number of beams 4. Now it generates token IDs corresponding to each recognized text, and it stores here, and further it is worked upon by the text decoder to get the letters. Here is the output which we got when we ran it on student 6 page 4. So this txt file was created, and as you can see, fairly accurate OCR was done, where you can read the letters actually quite accurately, right? And so in this way, we ran it over nearly all the data set which we had, and we got its OCR.
So as we are done with the OCR part, now the main picture that natural language processing come into for calculating the stress analysis. Uh, exactly, we have to quantify the stress. So main objective is to identify the psychological stress from the OCR extracted student writing. Then we will be approaching through deep learning, that is the NLP part for sentiment classification with the information theory, that is the entropy of information theory of what? That is our model, how our model is performing. We have also put some weight for that as well. For model selection, we went for the Twitter Robot A model that it is a finely tuned model on Twitter dataset. Why we choose this model, we will come into that as well. For the base sentiment latest, optimized for noisy short text like tweet or handwritten OCR content. Output will be a numerical stress index that will be ranging from 0 to 1, as we will be using the softmax function at the end. So it will be transformed into a probability like things, where higher value indicate greater emotional instability. So the diagram is as follow. Input text extracted from the OCR of the student response will be the input for this pipeline, and then we will be tokenizing our text. Uh, why tokenization is important? Because computer only understand the IDs, ID of numerical value, not the text. So we have to tokenize it using the auto tokenizer. We are using auto tokenizer as we don't need to change the entire code, just we have to change the model name. So it will be the same, that's why. For sentiment classification, we are using Robert A that predict the probability distribution. Uh, and our output will be as a probability distribution of all three, negative, neutral, positive, all three. And the entropy computation measure uncertain. Entropy is what? Entropy is the randomness of our model, how random our model is. If our all the positive, negative, neutrality all are in the same ratio, then our model is very random. So entropy will be high. That will suggest a higher stress. So if any probability is high, suppose if a person is highly positive, is positive index is zero point 0.9 and negative is zero point 0.1, like, so its entropy will be less. So it will be in the uh, less stress. At last, we will be computing the stress index. That is a weighted combination of negativity, uncertainty, and optimisms. And output at last will be a JSON file that will be showing the stress index, sentiment, and entropy for all the students. So why we choose this model? Various model was also in our option like BERT, Distilbert, Albert, and Robert A. For BERT, is that problem is that it's a slower in a smaller text, as answers will be written in the smaller text, so we have to perform well on that script as well. So but discarded. Distilbert, it's a lightweight but less context retention. It has a uh, LSTM is very low for distill, but it doesn't store the previous memory very well as compared to other. So we discarded it as well. Albert is a memory efficient but weaker on noisy informal data. Like answer script is there, so informal data will be there. A noisy data will be there. So at last, Robert A, it's a improved pre-training strategy. It is using dynamic masking plus large corpus. That is the best for text sentiment. Thus, Cardia NLP Robert Butt held a better generalization for OCR text, offering high precision on emotional tone. So that our code begin as follow. We are defining a class set a stress analyzer. We are using the initialization function with input self model device. This class performs sentiment-based stress analysis using a pre-trained robot model, initializing the function and tokenizer from the Hugging Face. That we are using auto model for sequence classification and auto tokenizer. Automatically, we are choosing between CPU if CPU is available or GPU if GPU is available. Else, it will be running on CPU as well. Um, when we defining the sentiment labels as negative, neutral, and positive, we will be getting all three scores. Uh, and then we are using the for self model to eval to get all the three values to disable training gradient and improve interference speed. We are using auto model and auto tokenizer to ensure flexibility as for easily swapping of the model without changing the code. Then we'll get the sentiment score a function. We are giving the parameter as text that we got from the previous one. It generates a sentiment probability for a text given text. It tokenizes the input text with padding and truncation to handle variable length sentences. It disables gradient computation with torch dot no grad. We don't want gradient computation for faster and memory efficient interface. And then we are feeding this token to model to obtain a raw logits, and then we are applying the softmax function so that everything will be converted and normalized into probability. And at the end we are returning a Python directory that will be mapping to each level. If negative for example, negative is zero point 0.2, neutral is zero point 0.5, and positive is zero point 0.3, all three will be summed to be 1 as we are using the softmax. And also one special thing that we are using here is the entropy thing. Entropy that measure the randomness of our own model. If our model is very much random, entropy will be very high, and it will at last compute to the stress. As we are putting the 30% weight to the entropy as well. So we are computing the Shannon entropy, that is the summation of minus p log p. P is my output that we are getting. Suppose we got in negative zero point 0.2, neutral zero point 0.5, positive zero point 0.3. So while calculating the entropy, it will be minus zero point 0.2 log zero point 0.2 minus zero point 0.5 log zero point 0.5 minus zero point 0.3 log zero point 0.5, zero point 0.3. So it will sum to entropy. We went to giving the weights as follow. We are giving negativity as 60%, entropy as 30%, and 1 minus positive. That is the lack of positivity. We are giving it 10%. That captures emotional disorder plus low confidence writing as well. So our output will be as follow. We can see that student 6, page 4, negative is zero point 0.1, neutral is zero point 0.8, positive is 0.003. So entropy is this stress index from the weighted sum we are getting.
Yeah, so now let's discuss the problems we faced in this process. So, first of all, we already knew and we were already aware that since this is a unsupervised learning and we are taking a heuristic approach, We don't have a training set basically. We don't know the stress that the student was undergoing because we only had their answer sheets and not themselves, right? So this actually creates a problem that we don't have a no stress baseline because we can't measure this thing objectively, right? We don't have an absolute value for this, and we can only find a relative value of that. So what we basically the foremost problem was that we needed to find a way which does not require an objective measurement and can be also done relatively. The next one was that we there was an obvious fact that actually marks awarded by the teacher is not a reliable measure of stress, right? Often the more studious people who score better marks are writing their exams in stress, while the people who get lesser marks are in less amount of stress. So we had to find a new metric which could define the stress. And at the end is the inaccurate OCR. So if the OCR outputs are inaccurate or they give the wrong words, and if there are unrelated characters appearing somewhere, we it can actually reduce the effectiveness of the code which we have developed, and features like entropy could also get corrupted. So how did we? So let's first of all see the illustrations of what we faced. First of all, was this was the model which we chose, which was Tesseract. We were trying to run it, but the problem we faced was that it was actually not able to detect. It was not able to uh, relate with the images which we had. So this actually didn't even run, right? So we got empty outputs. So this is the model text recognition error. Next one, which we tried with uh, our TROCR, but the base version. It actually gave us some words, but as you can see, this is not an actual sentence. It has repeated the same word twice, and this is not at all helpful for us. And so it actually detected the wrong text. Next one, which we got the error. This was slash zero, right? This error appears when the OCR model it is reading the text, but it is not able to understand the characters present in it. And this error, uh, which we got in TR-OCR base, where the words repeated and the text was inaccurate. For another page, this showed the zero space zero error. So this represents that there was a recognition error in the TR-OCR model, and it wasn't able to recognize the components of the page. So now let's see how we tackle these problems. First of all, we switched to the heuristic approach. We took a heuristic approach, which basically means an unsupervised learning. So what we did was we used a transformer. We used NLP and we developed a code which actually didn't require the a baseline or and knowing what the stress is already. And we actually compared within the same person's examination paper using the type of words he has chosen, the language he is using, and the relative performance in terms of these factors between pages. So if he or she is using the same type of words in the later stages, those type of those type of formation patterns get I mean they are a bit redundant for getting stress. While if the words are changing, we can detect that there is a fluctuation in the stress. So this is what we have taken as a measure of stress. And to tackle the problem which we just saw in the previous slide, these problems, we actually tested five models which we had mentioned earlier, and took the one which performed the best, and and to uh, and as a scoring metric, we used we used sentiment analysis. We took we actually devised three sections which we had discussed earlier about positive, negative, and neutral language, and also calculated took a weighted mean of these three to get the stress index and as well as the entropy, which we calculate from the formula which we learned earlier. So in the end, we use the TROCR large model to develop the OCR to get the text from the images. So let's now see what we observed and the what we learned from the data. So these graphs are for student one. So right. So here is the average sentiment distribution for the first student. So as you can see that our model was able to detect that 82% of the times he used non neutral words, but in the positive negative region, there were less amount of positive words which he had used and more amount of negative patterns which were followed by him. So this displays that there were some signs of stress in the person. And in this graph, this shows the trend of how the person's stress levels increase according to our model. So as you can see that, and which is actually a bit intuitive as well, that as the examination paper goes on, towards the end, the stress levels generally increase for the student because of the time constraints. And as it is clearly visible here, that the negative sentiment of the student is increasing with time, with the time, obviously. So by page 11, it has actually reached the values more than zero point 0.3, while the positive sentiment is reducing. So after taking the weighted sum and all, we get the stress index, which is also increasing, similar to that of the negative sentiment, right? So this clearly shows the increase in stress with time. Now we took a certain kind of anomaly in our data, which was seen in student three, right? So this is the analysis of for student three, who also had nearly 81% of neutral words. So neutral words involve the and all those kind of words which actually are used in every normal sentence, and we can't associate any emotion with that. But here you can see that his negativity is a bit higher. I mean, it is comparable, but it is a bit higher than the previous student. All right. And in the trend which we were seeing, we saw that there was a certain sudden spike in his stress levels during page 5, which eventually got reduced uh, further uh, when he or she moved further ahead. So the possible cause for this spike could be that he or she did not know the question which he was attempting in that paper, or he must have calculated wrong. And we checked it in the PDF, and there were a few cuttings in that paper, so probably that's the reason. And the our model was actually able to detect that there was something odd about it. Next is the sentiment distribution per page, which we can see here. So page 5, as clearly in the previous graph also it was visible that page 5 has a higher negativity than the others. Otherwise, the student was consistent with his performance. And we then plotted a negative sentiment versus stress index graph, and it nearly came it if we fit it with a if we do a linear regression, we can clearly see that they nearly lie in a straight line. And as the negative sentiment increases, the stress index increases, which is according to our weighted sum.
Hey, as we have reached to the output, like we got the JSON, we did the analysis. So no project is that doesn't have any future scope. Our project also has some future direction scope for future analysis. Like in this project, what we did, we actually did the stress analysis on the emotional tone, handwriting predictions, and handwriting analysis basically. So what the word he or she will predict, and we did the stress analysis on that. We can also do by ink thickness analysis is one of the thing that we can do in future. Cutting and overwriting, we can even analyze the cuttings and overwriting in the answer scripts, and LangChain integration that we can automate the entire process. So in ink thickness analysis is that investigating the correlation between microscopic ink thickness variation and short-term stress fluctuation during the writing session. Like when we are in the stress, we will be holding our pen tightly so that it empathize our stress level. We will be writing in the bold. It also a stress index. When we are in the light mode, we will be writing in the fluent way, so that ink index will be low. Cutting and overwriting, when we will be in the stress, we will be cutting our answers frequently and rewriting. So that shows the stress level. Uh, and the LangChain integration, like what in our project, what we are doing in the we are doing the stepwise. First step was conversion of the PDF to the JPG file or PNG file, and the second step was the OCR thing, and then third we are doing the stress analysis. We can even automate the entire process. Like we are just putting our PDF answered scripts in our local host, and that you give it this a direct result, and that will be saved entire in our folder. That we can also do. Various agents are there. One of the popular agent is the LangChain. We can integrate with the LangGraph in our local host Olama server so that it will be easy. Other are Crew AI and other agents are also present. These are the sample codes that we can do, like ink thickness analysis. In ink thickness analysis, it will come under the computer vision part. It will be the Gaussian blur. It will be finding the mean of that ink. Analysis. In overwriting detection, it will also come under the computer vision. It will store the contour. It will analyze the contour of the like what all the connected with that. If there will be a cut, that contour will increase and that it will detect it. For LangChain integration, we can use the sequential chain. We can automate the entire process in the chain. Like first, we are giving the input, and then it will be converted to OCR text. Then LLM will come. That LLM, whatever model we are choosing. Then Olama LLM will be our server. Just a sample Alama 3, just a free model that will be. It will be compatible with our lower level GPU systems, and then it will performing that task and it will giving the contextual stress explanation.
So, as we have discussed all the project, now we at last conclude with what is the novelty of the work. Novelty means how our work is unique from the rest of the cases in this in the internet. There are several codes of NLP, OCR, and that handwritten recognition. But how our work is different from that work? Because if our work is not novel, it is not no of use. First of all, we will talk about fusion of graphology and NLP. What is graphology and NLP? We have discussed already. So it is the framework combining handwriting pattern analysis, that is graphology, and natural language processing, that is NLP, to quantify student stress from exam scripts. So we are taking handwritten scripts and then we are doing pre-processing in that data pre-processing. Then we are applying OCR. Then we are applying NLP, and final we will get a index, the stress index. So this framework is not on the internet. We have created from the scratch. The answer scripts we have taken are manual answer scripts from the exam. So the data set is novel, and the NLP we have created is unique. So by this, the fusion of graphology and NLP, we have created a unique sort of work, or you can say project. The second we can discuss is OCR plus transformer based stress index. What is OCR plus transformer? We have integrated optimal OCR models like TR OCR and pedal OCR with Cardiff NLP robotic transformer for sentiment entropy fusion. And by this, we get a numerical stress index between 0 to 1. So you can use OCR and NLP, but we have integrated both OCR models like TR OCR, which is very good, with a robotic transformer. So it will give a numerical stress index between 0 to 1. Like you can say if we can talk about two stress index, zero point 0.3 and zero point 0.6. So the point 0.3 denotes that students is less under less stress in the exam in comparison to zero point 0.6. Third one is multi-model error, resilient pipeline. What is multi-model error? So we have introduced a five-model OCR voting mechanism and unsupervised anomaly detection to overcome lack of labeled stress data. So as we can see in this project, we do not have a labeled stress data. We are working on a unsupervised data. We have only the answer script. We don't need, or we don't have the grades of the background of the student. We only have the handwritten answer script. So we have introduced a five model OCR voting mechanism. By this, we can uh, overcome the unsupervised anomaly, and this also overcome that if a page do not run. if in a PDF file of we have from PDF we have created like 10 PNG files. So if in any PNG file do not run, our model skip that file and run on the further file. So it do not throw an error on the code itself. It will give a side notation that this page is not found and calculate the stress of the rest pages which is there. If we use single model, it can throw an error, but in this five model OCR mechanism, we have justified it by which model is best. It will use that model. The last is extended future scope. What are the future scope? Because in any project or any work, the future scope is must. Because if we have created a project and it is that sort of done, then it can't be reused or it can't be upgraded to that. So in our project, it has various future scopes like purpose ink thickness. We can propose ink thicknesses like in stress, human tendencies to write under hardness and we apply more ink to the paper and overwriting frequency if we are under stress or you can say under pressure. So we overwrite frequently. We do not have clarity in our mind. So we can introduce that thing. At last, we can introduce the lang chain integration. Lang chain integration, why? As we have discussed, my friend also discussed earlier, lang chain integration is very crucial in that we can only give a PDF file and that it finally give a stress score. So by lang chain integration, it will a sort of create a pipeline and the work is done in you can say seconds and the user do not have to do anything from that. Last is behavior based stress interpretation. So we can analyze the behavior of the student earlier by we can label the data earlier and we can do the stress indexing that way also. So the novelty of the work is justified by these 4 points and you can see the work is unique. Now we will demonstrate our code and see how the results will get.
Now let's go through our code. So I will be demonstrating the binarization part and I will be applying it on the student 5 images data which we got, and let's get a binarized image for that in the student 5 binarized folder. So let's first run it. We have already developed the environment which you can see here in the .venv file. Right now our code is running. So as you can see, all the pages were saved and we got the flag here. So let's check it out first. So here is the ACP binaries folder and student file. Yeah, so as you can see, here is the question answer sheet which has been binarized. It is incomplete grayscale and the thickness has also been increased. Next code is the OCR code which we are using. And here, first of all, we are running it for the same folder only, student 5 only. And let's run it, the trocr. So as you can see, the running OCR on images, this bar is coming. There are 4 images in this folder. So on every image, there would be a 25% increase in this bar. And when this becomes 100%, our work is complete. So the first page is done. So the main components in this is what we discussed in our presentation, and all of these are getting stored in the OCR folder. So here a student 5 OCR folder has been already created, and here are the binaries txt files. So as you can see, the entire text got saved here. Even the plus crosses, which these pluses are the crosses which it recognizes plus, but it doesn't matter. These won't be part of what the analysis. Yeah, so it actually understands the math as well, and yeah, it has understood most of the words. Right now, let's move on to the stress analysis part. So here is the code of stress analysis. I have already entered the student 5 OCR name, right? And now we are going to run it. So all of this would be stored in this folder, stress results name folder, right? 1.5 stress result folder. And it has all the components. For each page, it has done the negative, positive, neutral analysis, right? As it is clearly visible. And there is a summary folder as well, a summary JSON file as well, where it has found the average stress and it has stored all the data. So that's how our code works.